Today we're moving on to the quadratic function, factoring the graph, it says. This is the topic that we did in Year 10, our special topic, so a lot of this will hopefully sound familiar. The equation of a quadratic, in other words a parabola, can be given in three different ways. First of all, we have the general form of a parabola, which is y equals ax squared plus bx plus c. Okay, that form of the equation is obviously good when we want the quadratic formula, if we were going to be using that. It is also good if we want to use the axis of symmetry formula, which is, does anyone remember what that is? Axis of symmetry formula? Yes, very good. X equals negative b over 2a. All right, then the second type of equation that you can be given is bracketed or factorized form. Okay, so there's an example of factorized form. This type of equation is very handy to be able to read off your x-intercepts because they will come straight out of these brackets here. It's already factorized for you and you'll be able to find your x-intercepts of your parabola very, very easily. Okay, so each of these equations have their perks. Some of them require a bit more work to get other things though. The third type that we learnt about is the turning point form. Obviously, the benefit of this type of equation is that you can read the turning point straight out of it. This is your x coordinate here, and that one there is your y coordinate. Okay, remember doing that from last year. To sketch a parabola, make sure that you complete the following steps. You should always know what the y-intercept is, and that should be labelled on your graph if you have to draw it. You should always find and label the x-intercepts. And then it says there, find whether it is concave up or concave down. Concave up is your normal parabola going upwards, and concave down is your sad face going down parabola. Now, you can tell that from what is happening with the a, in other words, the number that is in front of the x squared. If that number is positive, then it's going to be the concave up parabola. If it's a negative number, it doesn't matter if it's negative 3, negative 10, any negative number is going to make that concave down. Okay, and that helps you with the sketching, that you know roughly what it should look like. Sometimes you may need to find the vertex or the turning point. Sometimes that will be easier to find than others because sometimes you'll be able to get it straight from the equation, or your turning point might be on the origin, the nice easy one. Okay, it might be very easy to get. Other times it might take a little bit more work. And we have a few strategies that we can use to do that. You can use the turning point formula. There it is again. X equals minus b over 2a. You can only use that formula when your equation is in this form, which means that you might have to expand brackets out if you had brackets. If it was in a different form, you might have to do some rearranging, okay, to use that formula. Once you have found your x value of your turning point, you then need to sub it back into your equation to find out what y is equal to. There were other ways to find the x value of the turning point. Does anyone remember that? Ooh, silence. If you have already found the x-intercepts, which quite often you have, the turning point is always right in the middle of those two x-intercepts. So you average them. That's another way to find it instead of using this formula. Okay, so if I knew that I had x equals 1 and x equals 3, then my vertex is going to be at x equals 2, right in the middle. You just go 1 plus 3 divided by 2. Yeah, to get that. The quadratic function down here. A quadratic function is a function that can be written in the form f of x equals ax squared plus bx plus c. Now again, there's a few people that are getting stuck on this letter at the front changing. The textbook likes to put different letters in there for some reason. Sometimes it was h of x or g of x or l of x. It's just trying to put it into some kind of function notation. It doesn't actually matter what that first letter is. Okay, but that is function notation. Once we put an equals 0 onto that, we have now made that into a quadratic equation, and we are pros at solving quadratic equations. Yes, we spent lots of time on those. The zeros and the roots. The solutions of the quadratic equation are called the roots of the equation. They're the x-intercepts, okay? We call those the roots or the solutions. The x-intercepts of the quadratic function are called the zeros of the function. So you'll hear that word. Find the zeros. It just means find the x-intercepts. Okay, that's what that means. So this is what we have to practice. Example number 1. Sketch the graph of y equals x squared minus 3. And a reminder there that we want to show the intercepts and the vertex, which we should always be trying to do for parabolas. Okay? So first of all, y equals x squared minus 3. Not too much has happened to that parabola. Remember, your basic parabola is the y equals x squared. The minus 3, all that is doing is moving my whole parabola down 3 places. So, hopefully, you can tell me what the turning point of that parabola is straight away. Anyone? Did you say, what did you say, Isaac?
0.
Yes, correct. It's hard to tell sometimes with the mask because it's muffled. So the turning point, normally the turning point is at 0, 0, but I've moved the y, everything's moved down in the y axis 3 places, which means it's now become 0, negative 3. Okay, so we can get that straight away just by knowing how to move our basic parabola around. That's the vertex, the turning point. Turning point and vertex means the same thing. You guys understand that, right? Yeah? Then I also want to find my intercepts. So just like we did with our straight line yesterday, if I want to find the intercepts, I sub in when x equals 0 and when y equals 0. So let's start with the x. When x equals 0. Subbing that in, I would get y equals, so I'm subbing into my original equation up here, y equals 0 squared minus 3. Obviously the 0 squared is not going to do anything. So it's just y equals negative 3. We kind of already knew that because that was our turning point, but that's okay. Then we want the other one. When y equals 0, subbing that into the highlighted yellow equation means I have 0 equals x squared minus 3. I want to solve that for x. So I'm going to move my 3 across to the other side. X squared equals a positive 3. And to get rid of the squared, I need to square root, which isn't particularly nice, square root of 3. But that will also mean that I get a positive or a negative. It's a quadratic. You've got an x squared, so you're expecting 2 solutions here. Okay, so plus or minus 3 for the x-intercepts. That is enough information now to draw it. Okay, it is a sketch, so it doesn't have to be perfect, but it does have to show all the essential features. So x-axis, y-axis. My turning point, I always like to start with the turning point, 0 minus 3. So 1, 2, 3, 0 minus 3 is there. You can either write it like that or you can even write the coordinate next to it. Is a very good practice as well. The y-intercept was minus 3, which I've already labelled. Y-axis minus 3, it's already on there. The x-intercepts were at a positive root 3. If you're trying to keep this roughly to scale, that's about 1.7. But remember, scale's not important here. And minus root 3. Okay, so there are the x-intercepts down through that vertex. And there's the parabola. Should also have known, I didn't mention it, but we should also have known that being a positive x squared here, that was going to be a concave up parabola. Sometimes last year, when I was marking people's tests, I knew straight away they hadn't checked, they hadn't looked at that x squared because they're giving me concave up parabolas when there was minus signs there and it should have been going the other way. And that can be a check for you. When you look at the equation, I know that's got to be concave up. And if your intercepts and your y-intercept, x and y-intercepts don't work that way, you've obviously made a mistake somewhere and you need to check. All right, question 2. Sketch the graph of f of x, okay, so it's writing in function form, which means the same as y equals, minus bracket x plus 1 squared. Okay, so that form of the parabola, when I put it in brackets, means that I'm moving the parabola sideways, doesn't it? Okay, so from the origin where my normal vertex is, I have moved it. What direction have I moved it though? Yes, left. So my vertex is going to be, or my turning point is going to be at -1, because it's always the opposite of what's in there, -1, have I moved the y value of the turning point? No. To do that, I would have had another number on the end here. If I had a +2 something on here, that would change my y value for the turning point. But I don't, so it's still at 0. Also to note, we have a minus sign here, so we're expecting a concave down parabola for this one. Let's find all our intercepts, our x and y intercepts. When x equals 0, subbing that in, I'm going to write y because we're used to finding the y value when we put it on the graph. Y equals minus, I have 0 plus 1 in brackets squared. Now 0 plus 1 is 1, 1 squared is 1, and a minus sign in front of that just gives me -1. Then I also want to try and fit in here when y equals 0. So y equals 0 is the f of x part, so 0 equals minus x plus 1 in brackets squared. Now I can move the minus sign away straight away. Okay, dividing a minus out, it's not going to do anything. If I square root the 0, it's still 0, and you don't have to have plus or minus 0, okay? It's just 0, okay? So all I'm going to get from there is that x plus 1 is going to be equal to 0. Move the 1 across to the other side. I'm just going to have to go across here a bit. I'm running out of room. X equals -1. All right, we have all we need to sketch. So my turning point was x equals -1, 0, which is right there. My y-intercept was at -1, which I'm going to put there. The only x-intercept that I have is at -1. Surprise, surprise, we already had that. We know this parabola is concave down, and we know parabolas are symmetrical. If you want to have another point on there, you could just come across one more to -2 to get both sides of that vertex. Yes? Then you connect up. And that's it. Question 3. So we're just putting another one in here. For the quadratic function, f of x equals 3x squared plus x minus 4. We want to find a few things. First of all, it says find the x and y intercepts. You're going to want to write small for this. Okay? So to do that, we sub in when x equals 0 into my function. That's going to be f of x, or y, equals 3 times 0 squared plus 0 minus 4. All right? That's 0, that's 0. So I just get y equals -4. Then I need to do when y equals 0. That's where the f of x is. So it's 0 equals 3x squared plus x minus 4. Okay, this is why I needed a bit of space, because to solve that, I have 3 terms. It's a quadratic. I have to factorize into 2 brackets, except on top of that, it's non-monic because there's a 3 out the front. Okay, so it's the harder type of trinomial. I need to times the 3 with the -4, so that's -12. I'm looking for 2 numbers that times to give -12 and add to give a 1. 4 and -3, good job. So we split the middle term to be a 4x and a -3x, because that was the 4 and the 3 that we worked out. And that's 0 equals. Then we factorize in pairs. Ooh, maybe I should take the first one and the third one. What do you reckon? Because they both have the 3s. Let's take we don't normally do that too often, but those ones definitely have a 3 and an x that could come out of them, giving me x minus 1. And that would mean I would take the second and the fourth term together, where I could bring out a positive 4, giving me x minus 1 again. Now that we have this bracket, which is a common factor, we factorize further to bring the x minus 1 out the front, and the 3x plus 4 from the front of each bracket goes into a second bracket here. Now that it's factorized, they're all 0 equals there, I can get my solutions. I'm just going to fit it in using null factor. So this first one here, this first bracket, I'm going to get x equals 1. That's the easy one, x equals 1. From this second bracket, remember the 3x plus 4 equals 0. So that would mean that 3x equals minus 4, and then divide the 3. Can I just write that down because I'm running out of room? Does everyone understand how to get that? So that's x equals minus 4 over 3 for my second x value there. Yep. All right, part B. We want to find the turning point, which is the vertex. All right, well, the way that this, I actually have choices here. Sometimes it's good to have choices. Sometimes it's confusing to have choices when you've got 2 different possibilities that you can do. I've actually got the x-intercepts here, so I could average them and I could find the vertex. But because I want to practice and remind you how to do it, this equation was in the form ax squared plus bx plus c. Okay, when it's in that form, we can also use the axis of symmetry formula, which is x equals minus b over 2a. Okay, you label the a, the b, and the c just like you do the quadratic formula. The a is the 3, b would be the 1 in front of that x, and the c, we don't need it for this one, but that would be the c that we would use if it was the quadratic formula. Subbing those in, I have minus b, so that means I have minus 1 over 2 times a, and a is 3. That is just negative 1 over 6. Okay, so I've found my x value. A turning point is not just an x value. You need to find the y value as well. So I sub that into my original function over here. Y is going to equal 3. I'm subbing in negative 1/6 for the x. So negative 1/6 squared plus negative 1/6 and minus 4. You're welcome to do that in your head or use your calculator. So minus 49 over 12, or as a mixed numeral, that's minus 4 and 1/12. So the turning point, I'm asked for a point, I should write it as a point, negative 1/6 and minus 4 and 1/12. Not very nice numbers. Now I know sometimes it's daunting when you're in the test and you know, oh, these numbers aren't working out very well and you're worried that you're getting it wrong. They're not always going to work out nice. Okay? Part C, state the domain and the range. We practiced this a few lessons, well, we've been practicing it for a few lessons now. This is a parabola. We haven't actually drawn it, but can you visualize it? It's a 3x squared, so it's positive. It's going to be concave up. Okay, we haven't been asked to draw it, but sometimes it actually helps to draw a quick sketch if you wanted to, if you can't visualize it. So we know it's concave up. We know this is where the turning point is, which means that's going to be the lowest point that parabola gets to. That y value there is going to be important, isn't it? Because that's the lowest point that parabola is going to get to on the y values. Is there any restriction on the x values that I can have? No. Okay, the parabola is going to keep going out like that. So I can have all real x. So domain, all real x. The range, however, we know that parabolas come down and they have that point where they turn around and go back up. So that's why I was talking about that y value. That's the lowest point that my parabola is going to get to, and that's the lowest point there, which is minus 4 and 1/12, which means all of my y values are going to be equal to that or above it. Cannot be lower than it. Okay, so y must be larger than or equal to negative 4 and 1/12. Okay, here's some new words. A new word that we need to know about. For what values of the curve, or for x, is the curve increasing? Okay, this is not your actual parabola, but a parabola like this, increasing, we've got the turning point, right? Turning point. We actually call that a stationary point. It's not increasing. Guys, don't get distracted. We're still listening. It is not increasing or decreasing. It's kind of stationary at that turning point. Everything on the left side here, we're coming down to that stationary point. So that's known as decreasing as you're coming down. You're working from left to right as you go across the page. That's called decreasing part of that parabola. Which means once I get on the right-hand side of that, that is now increasing. That's the increasing side of that parabola. So, thinking about this parabola that we haven't actually drawn, that turning point over here, that x value is now going to be important in telling where is it increasing, where is it decreasing. Now again, remember it's concave up, because if it was concave down, it would be different. But concave up means a similar shape to this, which means on the right-hand side of that x value is where it's going to be increasing. Yes? Which means it's going to be increasing when x is greater than the negative 1/6. Okay? One more question on the next page. Find the x and y intercepts and the maximum value of the quadratic function. So x and y intercepts, we know how to do that. When x equals 0, subbing it in. When x equals 0 into that equation, minus 2 bracket 0 minus 1 and 2 times 0 plus 3. We're just putting those in there. That calculates to be a 6. Okay, because this is just negative 1 times 3, so it's negative 3 times a negative 2 makes a positive 6. Then we do the other one, when y equals 0. So that means 0 equals 2 bracket, or negative 2 bracket, x minus 1, 2x plus 3. Now this is when it's good to have it factorized. It saves us having to do it. The 2, shouldn't be talking, not now.
Wouldn't that be a positive 6?
Negative 1 there. That's a negative 1, and that's a positive 3. So it's a negative times another negative that will be positive. This negative 2 out the front, this negative 2 out the front is not going to, you can divide it away. It's not going to do anything in terms of your x-intercepts here. Your x-intercepts come from these brackets here, already factorized. So from this bracket, we would get x equals 1. And from the second bracket, I've got a bit more space here, you get 2x equals negative 3. Divide the 2 across, we get negative 3 over 2, or negative 1.5. Okay, we have found the intercepts. It's said to also find the maximum value. That is going to be the turning point. Okay, because this has a negative sign in front of it, this is going to be a concave down parabola. So that turning point is going to be the maximum value that it gets to. Yeah? So we're going to use, we need our axis of symmetry. We could use our axis of symmetry formula. We practiced that last time, the minus b over 2a. My equation's not really set up for it. I'd have to expand this out to do that. So this time, let's practice the other method. I've got my x-intercepts. The other way to do it is just to average them. Okay? So my axis of symmetry is when x equals, I'm going to add together the 1 plus, what's actually a minus, a plus minus makes a minus, you all remember that from year 7, over 2. Add the two values together and divide by 2. We're just averaging those, and we get negative 1/4. We need the y value, so we sub that back in, because that's going to give us the maximum value. y equals into the original equation minus 2, negative a quarter minus 1, 2 times negative a quarter plus 3. And I know I've taken with a long time with the explanation today, so I'm giving you the answer at 6 1/4. When I'm asking for a maximum value, you are talking about the y value. Okay, it's always talking about the y value. So that is actually what we're after there. The maximum value is 6 1/4. That's the highest point that that parabola is going to get to. The rest of it's going to be concave down, coming away from that. Part B, we want to sketch it. So all that information going on a graph. We have a turning point, which was at the axis of symmetry, the minus a quarter and the 6 over here. These two things here, the x value and the y value, that would be my turning point. So minus a quarter and 6 1/4. Okay, so about there. Okay, because those are such weird numbers, it's probably a very good idea to write that one as a point on here. Like that. Identified the turning point. My x-intercepts were at 1. So that's going to be 1 there. And the other one was, oh, no, sorry. It was a positive 1. Positive 1. Erase, erase, erase. And a negative 1.5. Going to move that down a bit so it's a bit more symmetrical. So there and there. So from the turning point, we're coming down through here. I didn't put my y-intercept on there yet. I need to do that. My y-intercept was at 6. Okay, the turning point is not always the y-intercept. There it is at 6. So it's going to come down through the 6 and through that other x-intercept. There it is. One last bit. For what value of x is the curve decreasing? So as I'm coming across, sorry.
Oh, because you got to read the question carefully.
No, for B.
Oh, domain and range. All right, domain and range. Thank you. What is my domain? Domain is the x values, all real x. The range is talking about the y values.
Y has to be smaller than
Or equal to?
or equal to 6.
Correct. All right, thank you. Would have lost marks if I'd missed that, hey? All right, part C. For what values is the curve decreasing? So as I'm coming across here, this part of the curve is going up. That is increasing, okay, to my stationary point. And then when I get to here, I'm now decreasing. So it is when the x value, I want the x value, when x is greater than negative a quarter. So increasing, as you're coming from left, you always go from the left to right, it's like reading a book. As you're coming across, that is increasing, it's going uphill, increasing. The stationary point or the turning point is our part where it changes, and now it's coming down.